Energy is an everlasting problem for us. Global warming is at its worst due to fossil fuels. Renewable energies like wind and solar are not reliable. Why don't we let our friend the sun help us? It has been emitting tons of heat energy for billions of years through a process called fusion. It is a nuclear reaction but much cleaner and safer. And we think this may be the future of the world's energy industry. In the fusion reaction, intense pressure and extreme temperatures cause hydrogen atoms to fuse together, forming helium atoms. In the process, the atom loses some mass, which is converted into a massive amount of energy. The reaction could produce 4 times as much energy as fission reaction, and about 4 million times more energy than burning coal or gas. In other words, 1 kilogram of fusion fuel is equivalent to 61,000 barrels of oil. Additionally, hydrogen is used as fuel for the fusion reaction, so it is plentiful and doesn't contribute to greenhouse gases, making it much more reliable and cleaner than fossil fuel. Scientists have been researching nuclear fusion since the 1920s. Right now there are 2 common approaches to generating fusion energy. Inertial confinement, which subjects the fusion fuel to extremely high pressure for a brief amount of time. And magnetic confinement, which uses modest pressure for a prolonged time. Along with that, there are 2 types of reactors. The first one uses both confinements by uses a magnetic field, and the second one uses inertial confinement by heating the fuel with high-energy lasers. So fusion energy is another kind of nuclear energy, but it is nowhere near as dangerous as fission energy. When the confinement failed, then the plasma would expand and cool, and the reaction would stop, so there is no possibility of a runaway reaction. The radioactivity would be short-lived, so it is an inherently safe system. Fusion is really an awesome energy source. However, it is still considered a dream in our future. All the things we have now are experiments. There is an old joke that has been around for decades. Fusion power is only 30 years away, and always will be. It is still uncertain when fusion will contribute to the commercial energy mix. Perhaps in a few decades if fusion energy research is maintained with strong governmental support, realistic funding, and international collaboration. Besides, the efficiency now is still low. The current record for magnetic fusion power is 67%, although it's still a long way to reach 500% as the economic break-even. All efforts are aiming to operate a demo plant around 2045 to 2055. The questions now are, what are the necessary steps toward the end goal of a fusion power plant? Are the plans consistent with the current progress? Are the government's commitment and spending enough to close the gaps in science and technology soon?